So thank you for the opportunity to be here at my workplace, and I'm also happy that we can welcome so many of you, many familiar faces, and also organization we are very happy to cooperate with. So comparing to the family search, we have a much modest ambition. We don't want to put together, we don't have to put together the family tree of the humanity. We have to do only with the family tree of Hungary. Much easier, you can imagine. So actually a project is of course, we have a lot of holdings, a lot of collections related to family history in our holdings. But with this, in our focal project, now we are focusing on the civil registers. Actually, civil registers is something, it's very obvious that it's more or less accurate data about the births, marriages, and death of the people lived in Hungary. So with this project, we use a huge quantity of records. In 22 different locations, we have almost 40,000 books of this. You can imagine that how challenging it is to scan only this. Just think about the logistics, that we have to collect these books from the county archives, we have to bring these volumes here into our scanning or digitization workshop, also to register each books and so on. Altogether, this quantity takes almost 2,000 kilometers just in putting these books side by side. And it consists 23 millions of pages. The time span is from 1895 from 1980. So the inauguration of the civil registers in 1895 was also a very interesting story because before we had church registers, what we had to rely upon, but the Hungarian state wasn't satisfied that, and it generated a lot of debates, even tensions between the denominations, particularly because of the mixed marriages. So it was a question always between the denominations, Christian denominations, that in a mixed marriage, that which parents should be, or the children, which religion should be followed on, the fathers or the mothers. That was one of the challenge. The second challenge, why actually the state had to step into this process, was the different conditions by the different religions. So for example, marriages, the conditions of the marriages was different for the Catholics, different for the Protestants. Just the age limits of the people who involved in this marriage. So and also the divorces, conditions of the divorces were different. And many times it was tricky that it was easier to change the religion instead of getting into following the conditions and the requirements of the denomination. Catholics were very strict about the divorces. So this is particularly for this marriage law and this kind of constant fight between the religious community. In 1895, the law made it mandatory to have registration of the birth, marriages, and the death by the state. It wasn't easy at all. In the final vote of the parliament, there was only 5-vote majority for favoring this law. So it was a very thin majority of this decision. But of course, we have now this kind of almost 40,000 books, what we have to process, and I think everybody, not only the family researchers, the people who are going after their identity, local identities, but of course the academic researchers are very keen about this, because this collection, this huge collection can be used for historical demography, family reconstruction, social history, economic history, the history of health, pandemics, and so on. So we decided to make this, and because of the huge quantity, it's not possible to do it in traditional manual way. It's very obvious, but we are not the only one who try to do this. You can see in this picture this kind of western diagonal that other national archives are also trying to do something with, not only with the civil registers, but tax registers, military conscriptions, tax conscriptions in an automatized way. In different way, the most advanced are Scandinavians. They are investing a lot of money, effort, and time in order to develop solutions in this area. You can see this kind of small icons beside all of these national archives, that how different paths they want to follow. Many of them, this kind of house icons, indicates that they try to do something inbuilt development. For Germany use contractors for doing that. Regarding the handwriting text recognition, many use the very popular transcribus services, but we concluded that transcribus is a very tricky way, because their pricing policy are not really fit into the requirement of the National Archives, because we have huge quantity of records. And if we try to transcribe them automatically, better and better models exist and will be existed. So we have to do it again and again. And it's a huge amount of money. We cannot afford that. So according to the current prices of the transcribus is 25 euro cents to transcribe one page. And we have 23 million pages, and we have to do it repeatedly, so it's too expensive. So this is why we decided to develop our own pipeline in this, and also because even from family search, our challenge is a bit different. We have a lot of similarities and a lot of things common, but we also have a lot of differences. So our pipeline looks like this, and to be honest, it's not sophisticated enough in the final part, because in the last half a year we recognized that it should be more divided, and new subtasks or workflow sub-processes should be added. But of course, we have to scan this, we have to classify the images, we have to segment it, we make some kind of preprocessing before the handwriting text recognition, and training the model. We have to run the model, and we also have to upgrade it with kind of post-processing actions, and link the persons, find how a specific occurrence of one person in a civil register entry can be connected to other one. How can the birth register entry be connected to the death register entry? And whether we can say that this occurrence are about the same person? What kind of confidence? This is what I would like to show you in detail. So regarding the scanning, so we decided to scan the originals. So we are very happy that we have a cooperation from the 60s with the Genealogical Society of Utah, and it's a very good one. So I think we were the first in the region, particularly from the communist countries, that we had a contact with the Genealogical Society, and we have a lot of microfilms. But of course, we would like to have a better quality of these documents, and we would like to have a homogeneous collection, because this homogeneity could support this mass processing. So, in the green, in the center, that is Pest County, and we are doing this now. From the others, the orange, we have the microfilms and the digital copies of the microfilms. At this moment, you can see there are some white spots. I hope, because István responsible here for the digitization, so I hope that I accurate in these white spots. But more or less, even if I made some mistake mixing some actually generally it's more accurate, because almost the whole country is covered, and I hope that we will have a kind of cooperation with the Budapest City Archives also in this, because they have the registers of Budapest, of course. We try to make it efficiently. So we invested to buy robotic scanners in order to make this process more efficient, and we have a couple of them. We know very well that there were bad experiences in some project like this. So we invested also a lot of energy in order to find the best equipment, fine-tuning them, customize it for this process, and I think István can tell it that we are satisfied with the current process. So we have at this moment 3 of them, but we plan to invest in more than them. So we do the scanning, and then classification is also a challenge. So our ambition is not to make it full text searchable, but we would like to put this data into a database. So we would like to transform this content into a structural way. Actually, users want to search by the different data types. Full text search is good, but if we provide full text, they want us to make structured field-based search. They want us to make aggregates. They want us to make more and more developed services, and this is why we decided to try to transform this data into a structured database and make it searchable that way. It's also a challenge. In these green boxes, you can see the different data elements. So these green area consists of different boxes. It's not so obvious from this picture, but it is. And the orange areas are the labels of the forms. We don't want to transcribe it and repeatedly put into our text, because of course it's not necessary, as it's not data, it's just labels. Okay, and I show you that we use a software, in-house developed software for this, in which we can add the descriptions to all these labels, all these boxes. We can add metadata to all these boxes. So when the extraction is made from the original page, the image, all these boxes are labeled and added metadata, whether it is a handwriting, it is part of the form printed, and also the name and the use of this data. Okay, we have 52 different forms. It's a huge challenge, of course. We have to do this process with 52 different forms. In the beginning, when this kind of registration started, they used a one-page entry, a single-page entry. But in 1906, the Hungarian administration recognized that it takes a lot of paper consumption, and half of this collection based on only these 10 years. And actually, the modernization of the administration led to use spreadsheets instead. And since then, we have this kind of tabular data. Of course, different because it changed. In the beginning, they registered, for example, the religion of the people, religion of the married couple. During the communist, it was prohibited. Religion is something against the communist ideology. So people, most important, the occupation was during that time. And from the 80s, even the occupation is disappeared from the registers. So actually, these forms were evolving during the time. So this is the reason why we have so many. And as Thomas pointed out, the training of the AI, this transformation is very important. We also developed in-house software to help help to make this training data, and you can see that from the different and classified forms, we make the segmentation, this kind of polygonization of the different of the text, and of course we train them. I try to. Because it is not my equipment, but I try to show you this also. In live. I hope that I can, it will accept it. Okay. So all the selected randomized representative pages are selected for the training, and people, okay, I try to find something what I'm able to read. I think it's not typically this one. Okay, I'm going to cheat. Okay, it's Android. It's a settlement in Hungary, and I will add, I can add here the training data. This is what our volunteers or archivists and our specialists do. So try to read this text and train the model in this way. Okay, and I added one training data this way. Okay, so then we make the models. We have several models applied and try to improve it. So this is the problem why we cannot work with the transcribers, because we working with the transcribers is always an experiment. So as it's very good to hear that at the family search, they could read the Hungarian civil registers with 97% accuracy. Probably it's a character error rate is the 3%. But I hope that we will have we will be more accurate in the future, 98 in the future. And so we have to repeatedly rerun this model on the original text. Okay, and I show you that we have a demo for that, in which we apply now a former model in this. So we can use segmentation, but for this one single line, it's not necessary. You have some parameters what you can add in this service, and running the model. This is what we have hypotheses at the end, because the model gives back different kind of hypotheses of the written text, and we don't use the first one. Not always the first one is the best or the real hit. Many times we have the second, third, fifth feedback, which is actually meets the real text what is written there. And it is very important because we use this as an input for improving, for past processing the thing. Today, we have, luckily, to the large language models to improve this text and meet this kind of character errors, to correct these character errors with the help of large language models. And we can get back a good text with the help of grammatical accuracy, with the good words, what might exist in the Hungarian language. So we can do it, we haven't done it yet, but we made some successful experiments with the help of ChatGPT and the Hungarian local language model developed by the Hungarian Linguistic Academy. Okay, let's get back to this. Okay, I'm always worrying about the time, but I can show you that it works with a randomly selected text. Also, we get back the transcription, even if we add to this demo randomly selected or the prep. Of course, we can upload full pages, but it takes some time to run on the model, and I don't want to challenge your time. Okay, so we have entries, handwritten, recognized documents divided by the data, uploaded to the database, and then it's not enough because we want to build a family tree. So we have to connect the occurrences of the people, occurrences of the persons, and it's a challenge again. Luckily, as my director told you in the opening, that we have some experience on that. We did it also with AI, with the prisoners of war records. We got 700,000 file cards from the Russian archives with the data of the prisoner of records, prisoners of war of the Second World War, and the database related to that. We also had records about the people who could return after this thing, and we could link them together. We trained a model with the challenge is that these different sources have different attributes of the same people, and with the help of the AI, we could balance between these attributes, and the AI can help us to tell that which attributes are more important, to say that these two people, these two persons, or actually more accurately, these two occurrences of the persons might be matched. So, and this way we could reach a very good output, and we would like to use this technology also for the civil registers to find the parents, the birth data, connect to the death data, and together with these connections we can build the family tree. But whether we can, it's not so obvious. Okay, this is the portal of the prisoner of war records, where we connected the two different collections. Okay, so this is how it should be looked like, because among us we don't build a family tree. It doesn't exist a thing like a family tree. It's a network. Okay, families are related to each other, and it means that the persons are related to each other geographically, special way, and also in time dimension. So it's a graph. It's not a tree. Okay, we know that, but we don't have to communicate it this way. It's much easier to do it traditional way. Whether we can make it or not. And I think some challenging point in that, because this is the same challenge for us, and Thomas and Stephen mentioned that how can we construct this family tree or this graph, and we have a lot of challenges in that. But I mentioned that we use the AI for linking the people and linking this occurrence of the persons in the different records. But this solution doesn't bring back the 100% accuracy. So we have only back a connection with a confidence rate. This confidence rate can vary from 50 to 90, but never will be 100%. How can we represent this? What can I do with? What kind of service can I give to the users? I cannot say that you can see in this picture two families, and the connection between the two families are between a father name and another father name. And the confidence between them that these persons are the same is 82%. How should I represent it to the users? Can I tell them that these two persons, these two occurrences are the same? No. We are in an archives. We have to maintain the authenticity of our communication. And you could see that during the whole process, we used AI. We used AI in the handwriting recognition. We used AI in the record linking. And I cannot explain how these machine learning works. But at the end of the process, we have to maintain the authenticity. We have to prove the people that what we give information is solid as a rock. So it's a challenge. So we have to find a solution for that. And also the other thing is that as Family Search does, we also would like to use user-generated content and allow the people to add their readings, add their comments, or add their data to this huge database. But it's also tricky, because we don't know in this whole process which is the permanent thing. We are always redoing this circle, recognizing the bounding boxes, making the segmentations. The segments are not permanent. If we make a next segmentation, it might be two different segments. So we don't know which is the data which is permanent in the system. It's also a challenge. Anyway, we won't give up, and for this reason, we would like to cooperate with all the players in this field, and also because I told you there is no such a thing that family tree, and not only that, there is no such a thing that a family tree of a nation. It's very nice that we are on 2026. You will build the family tree of Hungary, but we are not only Hungary. Around this table are the archivists who are holding in their archives in the records of the families whose members are interconnected. So this is the reason why I'm very happy that not only Hungarian archivists, but also archivists from the neighboring countries are also here. Thank you for your attention.